we are going to walk through the buy and sell stocks problem. The scenario is sort of made up and unrealistic, but it makes for an interesting algorithm to talk about. So in the buy sell stocks problem, you have all the prices in advance for a single stock. You start with an unlimited amount of money, and you have the restriction that you can buy and sell the stock one time each. And what you are trying to do is figure out the maximum profit that you can make in this scenario. So suppose we have these prices. Even without talking about an actual algorithm to solve it, what we would need to know at any point in time is the maximum price that comes afterwards, because this is the price at which we would be able to sell it. So if we were to just go ahead and kind of by hand figure out what this would be, for the 5 case, the maximum afterwards is 10. Likewise for 8, and 4, and 7. For 10, the best price that comes afterward is 1, and for 1 is like nothing, so just 1. So knowing sort of magically in some sense the best price that comes afterwards, the maximum profit that could have been made if we bought at each point in time, is just taking the difference. So then we can compute the differences. This would have been a profit of 5, 2, 6, 3, negative, we'll just leave it negative, and 0. So for this set of initial prices, the maximum profit we could have made would have been the 6 here. So this is roughly how we could solve the problem. Let's go ahead and jump and see an algorithm to actually compute this. Now that we know what we're trying to do, let's go ahead and take a look at a basic algorithm to compute this. We're going to want to keep track of the best profit that we've seen so far. This is just a list of prices that is going to be input to the problem. And the key to an efficient implementation here is that we are going to want to build this highest after array, which for each index tells us the highest price that comes after this point in time. So let's go ahead and start stepping through this. We have best to 0. This prices array is just input. Highest after, we're going to populate them all with 0. This is an okay sentinel value because if the price that we're able to sell it is 0, there should never be a price lower than that. So the first thing we do is compute all the values for this highest after. And we can implement this by essentially taking the max value from what we've seen already in a highest after and the prices at that point in time. So let's step through this to get a better idea. We can see we're starting to walk from the end because it's prices after. So the aggregate information kind of builds up moving right to left. There we see 10 is populated. 10's higher than 7, so that doesn't change the new value populated. When we get to 15, the max of 15 and 10 is 15, so this ends up being a new highest value moving right to left. We can continue processing through the list, and we're going to see that 10 was the highest value to the right until we got to the 15, and then it proceeded to be the new highest value. And with this computed, it's very efficient to just go ahead and do one more pass through the array and calculate the best profit. So the best profit is always going to be the best of the profits that we've seen so far, and a new candidate, which is computed by taking the highest after value at some position and subtracting from the prices at that position, because this is the scenario where we bought at this point and we know that we were able to sell for some higher value later. So in the beginning, this 15 and 5 gives us a best of 10. Let's go ahead and keep computing. There was a 3, there was a 0, but the 10 is still better. Here's another 3, a 0, and a -1. So we actually found our best opportunity very early in this example. We end up with the best result of 10. Well, that's it. Hope you enjoyed this explanation, and hope to see you all on the next video.